Hello, so today we are doing this problem called swap nodes in pairs, and the problem says we get a linked list and we want to swap every two adjacent nodes and return the head. We may not modify the values in the list, we only should modify the nodes themselves, so the next pointers basically. And so the problem is that if we get, for example, let's say a linked list like this one, what we want to do is swap the every two pairs. So you can see here we swap 1 and 2 to be 2 and to 1, and then 3 and 4 to be 4 to 3. So that's the idea. So this is the output. And so how can we solve this problem? So usually one of the approaches to consider when working with a linked list is immediately a recursive, since linked list is by its nature a recursive data structure. So just thinking if there is a way to do to find a solution with recursion, because with recursion we know that we need the base case, and it's kind of fairly easy to determine the base case for a linked list. We know is if the node is not if not head, basically if the head is null. Sometimes we may also have maybe also not head.next, like maybe both cases are base cases, like the case of no element and the case of one element. And then we have the reduce to a smaller input size. With a linked list, it's usually also easy to know that we probably would do the call for swap pairs on head.next, because that's the only way to iterate on smaller subproblems with a linked list. With also now comes the operation part. That's a little bit where we can do the more the magic that will combine things together. So for a case like 1, 2, 3 here, if we think about it a little bit, what we need to divide into subproblems like this, because we want to swap the pairs, so we can, in each recursive operation, just swap one pair and connect it with the next pair swapped. That way we can, at the end, have a valid solution. So in our solution here, we can just do 2 to 1 and then connect that to swap for 3 to 4, right? And do swap pairs for the rest, which is rest, which is here in this case just 3, 4. Maybe if there was something else, we just pass the entire thing, right? And so now we just need to figure out how to do this step right here, right? So how do we do this step from going from this? And then of course we need also to not forget to connect to the swapping pairs of the next. So what this means basically is that 2.next becomes equal to 1, and then 1.next becomes connected to swap pairs, right? So 1.next becomes connected to swap pairs, right? So let's then encode this up into like a head here. So the head starts out as 1, right? So that means that 2.next is equal to head, and head.next is equal to swap pairs for, what is this 3 to 4? This is just head.next.next, right? This is head.next.next, right? For this here. What is 2? 2 is head.next, right? But since we override some of them, let's just put them in variables so that we make sure that with linked list pointers, we often get into troubles because we overrode something, right? So let's just, what is 2? Let's just put what is 2. So let's put this back into 2, and put this back into 1, and put this back into 3 to 4. And let's say, so what is 1? So 1 is just head, right? 1 is just head. What is 2? 2 is head.next, right? 3 to 4 to the rest of the linked list, that's just head.next.next, right? So let's just give names to these. So we know that the second pointer, which is this one, let's call it second because it's the second pointer, that's head.next, right? And we know that the third pointer that we are going to pass here, this one, that's the third pointer in the first case. So that's head.next.next, right? So let's just call it third. That's head.next.next. Now let's replace these. So, and we know that one is just head, right? One is just head. So 2.next, that's second.next, that's second, right? 2.next, that's second. So what we want to do instead is say so 2.next, 2 is second, right? So 2.next, that's just second.next, right? And that's equal to head. So third is also just second.next. This is just second.next. And then we know that we want to connect 1.next, right? So this is what we want to do. It's not 1 equal to that, is we want to connect 1 to this, like this. We want to create this link here. So 1.next is equal to this. So what is 1.next? That's just head.next, right? That's equal to swap pairs of the rest here. What is the rest here? That's just head.next.next. That's just the third, right? A third pointer here, so that's third. And so, is there anything else we need to do? We need to also link. So we initialized these variables and we did the link second.next. So what do we need to return to the caller? So let's say we were doing 3, 4 and we reversed it into this. So what do we need to return to the caller? We need to return 4, which is the head of this portion of the list, so that it can connect 1 to 4. And so what is 4 here that we need to return? That's the what is it? That's the second, right? In case of 1, 2, that's 2. If there was something else before this, we need to return 2 because that's the new head. Same thing here, we need to return 4, and that's the second. That's the pointer second because it's head.next. And so this is pretty much it. This is the operation that we need to do. So this is the operation. So we just need to put the values so that we set up here. And so we don't need this part. And now we have our recursion, and we have this. Now we need to not forget also our base case, which is if head. But since we're also doing third, which is head.next.next, we don't want to get a case where the head.next is null. So we need to also handle the case, this case that I mentioned here, so that we don't get null for the third here and then have a crash. So for this case, what do we want to return? We want to just return the head, right? And that's pretty much it. Let's run this. So that was the operation step. This is what I determined here was the operation, or basically combining the recursive calls. So we need to do self.swap pairs. Okay, so that seems okay. So that solution passes. Now let's think if we can find a recursive solution instead. So before that though, let's just go over the time complexity here. So here at most we are going to go through the entire list in this recursion. So time complexity is just, if we take n as the number of nodes, time complexity is just O of n. The space complexity though, because this is a recursive function, so there is in the stack like the number of calls that we all make, so the space complexity ends up being O of n. So what I'm hoping here, what we are hoping for is in the iterative solution, we can maybe find a better space complexity. We probably can do better than time complexity, than O(n) time complexity, because we will need to swap every pair in the linked list. But maybe there is a way to find a better space complexity of O(1) constant space. So let's see how can we do that. So let's see if we can find this. So the main idea with the iterative solution is to just do a simple thing, which is so let's say we have, so in our case here we have this linked list that we're gonna swap every pair for. And so what do we need when we are swapping? So let's say we are swapping 3 and 4. That would be easier because it has a previous element. We need a pointer to the previous element, right? And let's call the first element of the pair A, and let's call the second element of the pair B. So what's happening here is that pre is the node before the pair swap. And A is the first node of the pair, and B is the second node of the pair. And our goal here is to end up with something where whatever the pre was, we want to end up with pre and reverse the pair so that B is first and then A and then connects to whatever is after that, right? So if I want to generalize this, it would be pre, whatever was before, pre, and then connected to pre, and then at first I had something like this. So that I had something like this, pre. This is basically for each iteration. I had something like this, and this was connected to whatever B.next was, right? And then A, I wanted to be connected to B.next, and then we will continue in the iteration and do whatever next here. And so my pointer will need to move from being here, let's call this X, and let's say we had a pointer to X called pre, right? So I want my pre pointer here in the second iteration. I want it to move to B.next to just A, so that B.next can be swapped with whatever was after that. So basically, let's say there was here's another value Y. I want pre to be A, and then I want to swap these both so that pre will connect to Y, and then Y would be connected now to the previous B.next, right? And so basically by just doing this iteration of swapping, keeping track of pre, the previous node, and then swapping A and B here, and then doing the second iteration where pre is at A, I can solve the problem, right? So what do I need to do? What are the operations that I need to do? Well, I need to, for each iteration, I need to say my A is the pre.next, right? Because what my pointer here first is at X, the A is the one next to it before swapping, right? And B is the one next to A, right? And then now I do the swap. How do I do the swap? So pre.next will change because pre.next, instead of pointing to A, now will point to B. And then what else will change? A will now point to B.next instead of pointing to B. So A which will change. And B was pointing to B.next, now it will be pointing to A. So that one will change too. And so in Python, there is this expression that can change multiple values at the same time without any assignment affecting another one. And so that's really useful for these pointers technique, because if we do them in the wrong order, we might end up in trouble. So let's just do them all at once and not risk having any issues. And so pre.next will need to point to what? So pre.next will need to be A, right? And so let's say, no, sorry. So pre.next will need to be B, right? And then, so that's this. And A would need to change whatever it was pointing to. It was pointing to B, and now it will need to point to B.next. So A.next will change to be pointing to B.next, right? And then B.next will need to change where it's pointing to be pointing to A, right? To be pointing to A. So this is what we are changing, right? And so we do this coupled with this first iteration, and then we need to go to the next iteration, but before that we need to point pre to A so that it can help with swapping this, right? And so we need pre to become the value A, right? And then that's pretty much it. The only thing we'll need to handle is, what about this, the first case in the head? How do we swap these? Because we don't have pre at that point, right? Pre is not pointing to anything at that point because there is nothing before them. And so we can just use the dummy node technique, which just consists of creating a dummy node of list.node that is 0 and making that pre that connect to that. And now we have a node here, dummy, that is connected to that we can swap and make pre here and make these be A, B, and do the same operation. And at the end, we can just, when we do the while loop, at the end, we can just return dummy.next to give the final result, because dummy is not part of our linked list, right? So let's just implement this then. And so what we need to do is we need to first initialize the dummy node that we said. So that would be these two operations first as an initialization step. And then our dummy node needs to connect to this. And so actually I can just say pre.next now is head, right? And then I can do the while loop like this, where when should we stop? So we should stop when pre.next, whatever previous value is pointing to, is null, right? Because then there is nothing to swap anymore. So so when this is null, or also when there is just one element, let's say the list has has odd number of values. Let's say the list is just 6, right? And our pre-value is here, right? There is nothing to swap 6 with, right? And so no need to proceed. And so in that case, our pre.next is non-null, but our pre.next is null, which means there is no more 2 other elements that we can swap later. And so we need also the condition that pre.next exists, right? And now we just do these operations. So let's just take them like this. And after that, what we will have to do is just do what we said here, which is we want to return dummy.next after that. And that's pretty much it. Okay, I'll submit. So that passes. Cool. But one thing that may come to your mind is that okay, I'm using Python, so it's easy for me to do this, but what if I'm not using Python? What if I have to use another language, let's say Java or something? How can I accomplish this in a way that doesn't require this Python capability? And so we definitely can do that too, so let's just think about that for a second here. So I think there was a drawing that could help. 1 second. Yeah, whatever, it doesn't matter. Sorry, let me just do that instead by hand here. So the idea is, let's take the value here. Let's say, so same thing, we'll start with the dummy because that always helps with the implementation for the first node. So that's 0, and let's take 1, and let's take 2, the same list that we had before, but let's just take this simple list, right? And this is the last one. So this one is the first, and this one is the second. So what do we need to accomplish? The first step, we can just take this here, right? We can just put current here at this position. And then the first step we will need to do is just say, okay, step 1, let's just point current, instead of pointing to 1, we want to point it to 2, which is second. So point this one to second, which means we'll end up with something like this. We'll end up with 0 pointing to 2. And then we'll end up to 1 still pointing to 2, right? That didn't change. And then we'll end up with null, 2 still pointing to null. So 2 also still pointing to null, which I don't know how to do. So we can just draw that like this. So 2 is still pointing like this to null. So it's pointing like this to null. And so we have that for the first case, right? Now, so we already did one step, right? Because remember, the final result we are after is having 0, 2, 1, and then have 1 point to null, right? And so the second step we can do there is saying, okay, first dot next is going to be pointing to, so this one is still first, and this one is still second. We didn't change that yet. And so, but the final result is going to be like this, right? This is the final result. This one is second, and this one is first. So we are going to point first dot next. Instead of pointing to 2, we're going to change it to be pointing to null. And so this one is going to be pointing to the second dot next, right? And if it was another list, let's say 3, 4, then it will point to that, which is what we want, right? And so our final result with that would be something instead like this, where 0 is pointing to 2, but 1 is no longer pointing to 2, it's now pointing to null, right? So you can see here, now what's missing is the link between 2 and 1, right? And so in our third step, what we are going to do is we're going to do the link, which is, so this is second, and this is first pointer. That didn't change. So what we want is we want second dot next to be first, right? And so and our current pointer, I forgot to mention that, is still at this position since we haven't changed it yet. So our current is still at this position. Once we do second dot next, now we will have something like this, where 2 would be connected now to 1. And so you can see this is pretty much our solution here. And so we are almost done, but in case there was, let's say, another list here instead of null, in that case what we would need to continue somehow. So we need our current to move to here, so that it can, just the same way that it was before, the 2 pairs that we want to swap, in this case, want it to be here so that it can be before the 2 next pairs that we want to swap, right? So how can we do that? We can do that by just saying that current now is going to be current dot next, right? So that it goes from the first element of the pair, the second element of the pair, and that where it needs to stay, so that it helps swapping the other elements after that, right? So we know now all we need to do, the steps we need to do. And so now we just need to implement this. And by the end, we will have what we need. And so first thing we need is we need to handle the case where there is not a first and a second, right? Because there is no swap. So in that case, we can just do if not head or not head dot next. So there is no first in this case, and there is no first and second in this case. There is no second only. So this case, there is no first and there is no second. This case, there is a first, but there is no second, so no need in to swap, right? And so we need to return, in this case, just head. And then we need to create our dummy node like this. And then we will need to say dummy.next is going to be equal to head, right? And then we need to make the current pointer point to that dummy. And then we need our while loop now, which will stop when current becomes at a position that is pointing to null, that there is no element, or that is pointing to only one element, so there are no two pairs to swap, right? So while current.next, so there is at least one element, and current.next.next, which means there are two elements, so there is a pair we can swap. In that case, we just need to do these steps: the first step, the second step, but we need to first set our first and second. So first is just current.next, right? And second is just first.next, right? Right? Or let's just make it clearer by saying it's current.next.next, right? And then we can start doing the iteration steps, which are this one first, and then the second one, and then the third one, and then the third one, which is the last one. And at the end, since we have this dummy node, we need to return dummy.next, pretty much. And that's all there is to it. So you can see we did this step by step, making sure that we didn't mess up anything in the order that makes one of the pointers not connected, or one of the pointers overridden by something, right? So it's we called it first. So okay, submit. Okay, so that passes. Now in terms of time complexity for this solution, we can see we are doing just one pass that goes through the entire list, so it's open. And in terms of space complexity, this time we are doing an iterative solution, and so the space complexity is we are just using a couple of extra pointers, dummy, current, first, and second, and those don't add up too much. That's just constant space, and yeah, so that's the complexity of this solution. And yeah, that's it for now. See you next time. Bye.